This is lesson 5, founder effect. So last time we looked at bottleneck effect, and we compare and contrasted allele frequency before the bottleneck event happens and after the bottleneck event happened. And you would have used the simulation to produce the graph and the tables. And what I should be able to see from your table and graph is that when your founder event has a lot of, so basically you can compare the colors. So this is a yellow allele frequency, blue, red allele frequency. And you can see that if you only have two surviving individuals, you'll have like a really drastic change. So the blue column should deviate most from the zero line. And if you have 10 individuals, you have more survivors and the difference will be slightly less than the blue. And then if you have 200 survivors, then you should have a larger surviving population, which kind of minimized the effect of genetic drift a little bit. And therefore, you should see the least change from the original frequency. So in conclusion, you can see that it doesn't matter how many survivors there are because you have a reduction in the population. The new population's allele frequency are almost never the same as the original one. It will always deviate from it, slight difference. And yet, if you have less survivors, the more change, the more deviation you see in the new population's allele frequency from the older population. So just remind you that the bottleneck effect talks about how you have an event that will minimize the population, reduce the population by a large amount. So the surviving group is like a sample of the original population, and it doesn't fully represent the original allele frequency very well. And the smaller the sample size, the less accurate the representation is, and therefore you see more changes from the original population. Okay, so let's come to this lesson and we're going to talk about founder effect. So please write this down in your lesson objective. We've moved into this next one. So remember bottleneck effect and founder effect, they kind of all happen under the effect of genetic drift as well. And genetic drift is basically the fluctuation or the random fluctuation of allele frequency when a newer generation is being produced, and you see this little change of allele frequency over time. Okay, now to understand founder effect, there is this really good video with animation. So if you click on that, it is produced by Amoeba Sister. Have a watch, and then we'll come back to this. All right, so when we talk about the founder effect, this is the definition. It is a reduction in the genetic variation that results when a small subset of a large population is used to establish a new colony. So in saying so, you're breaking off a little group from the original population and use that group to create a new colony somewhere else. And that little group that breaks off, they're not always a good representation of all the alleles that were originally in the population. You can see in the butterfly example right here, the original population lives on an island, and then suddenly you have a little small group, 3 individuals breaking off and flying to a new island and establishing the colonies. And you can see that the white allele is there are no longer white butterflies, right? Because they're very little small a. So if I actually zoom in a little bit, you can see the allele on the butterfly. So big A, big A, big A, small a, and small a, small a. And again, you can see that this is a incomplete dominance. And originally, you have quite a bit of small a alleles. Like the amount of small a and the big A are equally the same. But when you have a little colony breaking off, you can see that there's only one small a allele left, and the rest of them are big A alleles in these, producing these darker wing colors. So what I want you to do is pause the video for a bit and come up with some scenarios where you can get a founder effect, where there is a small group breaking off from the original population, starting a new colony, new population. Okay, so assuming that you've attempted it, let me give you a couple of examples. Usually animals that migrate or fly is a very good, it's a very common effect that you're going to see, because it's very easy for them to break off from a original population, go to somewhere else and establish a new population over there. New Zealand and Australia has a huge problem with rabbits and rats. Because New Zealand and Australia is so far away from the rest of the world at bottom in the southern hemisphere, we don't get the same evolution that you see in the rest of the world. We did not have any rabbits before the Europeans arrived. We did not have rats on the islands when the Europeans arrived. And what happened was, when the sailors and the traders come to New Zealand, Australia, they brought with them, well, the rabbits were intentionally brought with them to New Zealand and Australia for fun, because hunting was a sport and they did it for fun. They didn't want any rats there, but somehow rats got onto the ship and went with them together to New Zealand. And this was like catastrophic for New Zealand and Australia. A lot of the native birds, a good amount of them actually disappeared, because the rats would prey on the eggs of these native birds to New Zealand. And it has hugely reduced our genetic, our biodiversity. So these are some of the examples of a founder effect, where the rats come from a different island and came to New Zealand, which originally we did not have any. Okay, again, I'm going to get you to do a little simulation. It is one that you have done before. So use the simulation to see how alleles can change after founder effects. So in the simulation, I want you to set the main island population to 500. And then I want you to set up 2 islands. So island number 1 and then an island number 2. You can create your new founder. You can drag a group of founder and you can put it in here by clicking these colonize button. So the first island, this one, I want you to set the founding population to 50, meaning that 50 individuals from the main island is going to be coming to island number 1. And this K is the carrying capacity of the island. So how much individual are able to, is the island able to support? So I want you to drag these 2 bars to 200 for both of the islands. And then for the second island, set the founding population to 2. So we have a very small group of colonizer. Once you've done that, you can click go. After you have recorded, after you have set everything up, once you click go, you're going to see a generation running, and we're going to click colonize, and it's going to drag 50 individuals and start colonizing it. Then if you click colonize again, you get 2 individuals, and then you can colonize this island as well. Run it until it reaches a generation of 100. And then you can click go again to pause it and record the difference in allele frequency in the main island and in these islands. Again, there's a Google Sheet for you to record your data. So founding population of 50 and founding population of 2. And then a graph will be generated. And I want you to copy and paste the data table on the graph here. And then make a few observations. What do you notice? What could you observe? What are the major differences? And then once you've done that, you should be able to see that the larger the colony size, then you're going to see a smaller deviation or smaller difference from the major population. If you have a smaller colony size, then the allele frequency in the new colony is going to be very, very different from the original one because of the sample size. Okay, so once you've done that, I want you to now think about what is the difference between a bottleneck effect and the founder effect. Because if you look at the conclusion and discussion, there are some similarities between them, but then there are also some fundamental differences between these two effects. How do we differentiate it? Because in the test, I will be providing you guys with a scenario, and you guys need to determine whether that's a bottleneck effect or whether that is a founder's effect. Okay, so I'm going to stop here. Take your time.